We're very lucky at the University of Liverpool. We've developed our facilities over the last 10 years or so, and we have a number of different levels of fidelity of flight simulators. The simulation trial is set up to be an accurate representation of the real-world flight trials. The benefit of using a flight simulator is that we can look at a range of different conditions very quickly. So we can look at things safely and very quickly and efficiently in a way that you can't necessarily do at real-world trials. In the early days of the helicopter ship work, we were using very, very simple models that were analytical models that didn't have a very strong background in terms of development. Since using Ansys products, we can actually improve the fidelity of those models to an extent that the pilots give us very positive feedback in terms of the realism of the encounter that they're having at the back of a ship.
So the challenge here for us is to produce a realistic environment. The landing missions the pilots have to undertake are dangerous, and they are, frankly, life-threatening. So the better the fidelity, the better the training we can give, the better scenario testing we can do, then that surely must have knock-on effects for survivability. One of the things we've learned through this research is that when a pilot does report a particularly difficult landing, wind direction, speed, we can then look into the CFD to see what it is that's causing a problem for the pilot on the helicopter, and then we can look at the geometry of the ship to see where it's coming from. And that opens up some possible future direction for us.
Using Ansys software to develop more helicopter-friendly ships has a number of advantages. Firstly, it's hugely cost-effective compared with the cost of flight trials at sea. We can run a number of design iterations. The risks involved with ship deck landings are obviously negated in our flight simulator, and we can also go back to the CFD to analyse the effect that different modifications and different ship geometries have had on the overall flow field, giving us a better idea of how we can manipulate the ship geometry to reduce the adverse effect of the air wake on pilot workload.
We've been able to validate our CFD results against a number of different experimental databases. We're lucky to have sources such as wind tunnel data, water flume data, and at-sea anemometer data. And each time we've compared our results against the experimental data sets, we've shown excellent agreement with the experimental results.
We can generate quite significant amount of data at very high resolution with the Ansys software, something that we can't deal with in real time with the flight simulators. The best thing about using the Ansys software, it gives us absolute confidence in the results and the fidelity of the work, so we can actually make real-world predictions based on the simulator work we undertake.